All right. Clicking the go live button. And we are live. Ladies and gentlemen, welcome to the Kosmographia podcast with Randall Carlson and, of course, friends. Got Brad, Mike here. And, so we are... This is maybe going to be a good show. Randall, what do you think? You think it's going to be a good one?
I'd say the odds are about 60-40 in favor of it being a good show.
Okay. In favor.
No, I think it's better than that.
You think it's better than that?
Going higher.
I think it's better.
62.
Well, now
38.
that we have Mike here with us.
Right. Yeah,
it's
Mike.
bound to be an exciting episode.
All right. That's good.
So,
always happy to brighten your evenings.
Yeah, I'm glad you're joining us for the lives, Mike. You know, got to be here for the lives.
You're welcome. Happy to be here. Happy to be alive.
All right, Randall. So what topic are we going to cover? What do you think?
Well,
we should talk about Halloween, right? Or Valentine's Day. Was it a holiday we're going to talk about? Or maybe the
Valentine's
Equinox?
Day?
We're going to talk about the
That's
Equinox.
It's an auspicious calendar day, right?
Well, I was hoping you ordered your gyroscope, right? You've got your gyroscope?
I do have a gyroscope, yeah.
Excellent.
Yeah.
I want to see your gyroscope.
Okay, well, it's in the car. I don't have it in the studio. Yeah.
Cool.
Go get it. Do I need to run out there and get it? I can do it.
Well, I was really thinking, this would be a very cool demonstration, since I think we're going to talk about solstices.
Okay.
Which means we'll be talking about precession.
Yeah.
And solstice.
And you were bragging about your new gyroscope. So I was just assuming you would have it there.
Well, it is technically here. It's just out in the car. I can go grab it. Not a problem.
Okay.
The interesting thing, though, is that I've been experimenting with it, and I can't actually make it precess. It will process. The axis will rotate at the same direction of the spin of the gyroscope. But if I ever force it to precess, it will do it for a little while, but then it eventually stops and goes in the other direction. I think this may have to do with friction in the bearings and gravity, and I don't know.
But yeah, I was reading about that, and they call that precession, even though it is going in the same direction as the spin.
All right.
Well, it's relative to
the
rest of the movement of the solar system.
Yeah.
So in other words, we define the rest of the movement of the solar system as precession.
Mm-hmm.
Since the equinoxes and solstices are moving in the other direction, it's called precession.
Right. And doesn't that mean that the precessional axial motion of the Earth is turning in the other direction than the rotation of the Earth?
No.
No.
I don't think so. I've never been asked that question before, but no, I don't think so.
Well, that's what makes it precess, right? Because that motion is actually going clockwise, whereas the Earth is spinning counterclockwise. I think. I could have it wrong. I've been known to be wrong before.
Well, let's get into it and see if we can't figure it out.
Okay, and I can go grab my gyroscope. Either way.
But at least that shows the axial motion.
Yes, it will. Yeah.
And that's
the key.
There we go. See, this is my substitute Earth axis right here.
That was my thought also, that it was slowly in the opposite direction of their spin itself. So yeah, I don't really remember anybody asking that or getting that 100% clarified. I just
and I
hate to say I assumed that, but I guess I did.
I tried so many different searches trying to ask the question, why does the precession of the equinoxes, like why does the Earth's axial precession go in reverse to its spin when a gyroscopic precession is in the same direction as its spin? And every website that I found on axial precession of the Earth talked about how it goes in the opposite direction of its spin, never talked about why. And then precession of a gyroscope would just talk about how it goes in the same direction and gave a bunch of reasons why. But there was no one that I could find that was addressing why these two things are different. So that was really strange to me.
Well, if you visualize that you're standing on the Earth and it's rotating on its axis, that means that you're looking to the west right? And you're seeing things set in the west, right? Now, if we assume that the Earth's axis is moving in that counterclockwise direction, you've got to be visualizing the Earth's equator projected out into space, and the precession is the intersection of the equator, the celestial equator, with the plane of the ecliptic. So if the Earth is rotating, like I'm facing due east right now, right? So sun would be setting behind me. So the Earth would be rolling this way. I'm sorry, rolling this way, rolling this way. So then things are rising in the east, setting in the west, right? So the Earth is rolling this way. Since I'm at about, 39 degrees latitude here, I'm tilted
34.
towards the north this way. So north is to my left, and it's rotating like this. Yet if I'm looking out here to the south, then the ecliptic is going to be moving towards the west. Is it not?
Yeah, I think so.
Well,
And as you go through the year, if you're looking to the south, the constellations will also be setting in the west the further
Yes.
along you go in the year. So both
Yes,
the
the
day cycle and the annual cycle have the same direction of motion of the stars.
yes, but if you're looking out there at the orbits of the planets, the sun or the moon, they're all going towards the east. So really it's a function of the Earth's rotation on its axis, and I think we can safely conclude that the rotation on its axis and its precessional motion are both the same.
It's that when you have that degree of change of the axis, you don't completely come all the way around full circle in the year before you hit the equinox again. And so now
Correct.
you're looking, so maybe that's what it is. The axis is, now you're looking at a set of stars that's gone
It's so hard
in
to
the
talk
reverse
about
direction.
this.
I know. But it's all
Well, this
about
is-
where the positions of the equinoxes are. Like you said, when you project the equator out, where the equator intersects, the equatorial plane intersects the ecliptic, those 2 points, like if it was, your equinoctial points, are going in reverse. Isn't that true?
I believe that's right. Let me think. So if the Earth is going around and we do not tilt the Earth's axis 23.5 degrees, then it's moving. Let's see, if we're looking from above, then it's moving counterclockwise.
That's right. Counterclockwise,
around the
looking.
sun.
Yeah,
So this is
Right.
precisely why we're experimenting with models
That's
and
right.
gyroscopes and animations and trying to
We're-
figure out how to make a display of this, because it's hard, it's difficult to visualize and explain it to people.
yeah, and
I got some graphics together that we can look at. Maybe it'll help us get the picture in our head, because it is a very complicated thing to get straight
Yeah.
in your mind.
and if the axial precession of the Earth is also counterclockwise, then I need to know that to build a good model.
yeah,
I don't think it is.
I don't
it's
think it
going
is
the other
either. I think it goes the other direction, but I could be wrong.
Edley, do you have a backdrop that would be a celestial dome with the stars on it?
Do I?
Yeah.
Not
We
that
could-
I know of.
Okay. Well, what we'll do for a future podcast is we'll get Bradley to get get Bradley. We'll put him a little hat with a pole like this, and his head can be the northern hemisphere, and then you can try various movements, and we'll
All right.
figure it out. Yeah,
Yeah,
go.
so I'm
See, there.
I'm seeing a diagram here on Wikipedia showing the axial precession of the Earth going in the opposite direction of the Earth's spin, of the Earth's rotation.
Let's
Upon its
have a
axis.
look at that diagram. Can you share?
Well,
that
let me pull it up.
diagram?
Tear it up.
Ooh, I can't share. You
Yeah.
you pull it up, Brad. I can't share right now because we're streaming and I don't have two monitors.
Yeah. You can find it on Wikipedia, I'm sure.
Yeah, it's the Wikipedia diagram just has it. It shows the arrows of the Earth's spin and the arrows of the axis, of the precession of the axis, right there. And so I just found that interesting when I was looking this up after he got the gyroscope.
I got the gyroscope, and I was talking about how I can't make it. I can't make it precess in the opposite direction of a spin. I mean, I can force it to do it, but it will stop and go the other direction.
The closest thing I could find to an explanation is that the Earth's axial precession, they claim, is due to a whole lot of factors. Planets pulling gravitational. It's a gravitational phenomenon with the moon and the sun and Jupiter and all these planets and things. It's incredibly complicated. Was basically the explanation.
Yeah.
Uh-huh. Okay. I think I found a good graphic here.
All right. I've got that one. You got something else? I've got the Wikipedia one they're talking about.
Well, let's see what you got. I don't.
Because, yeah, it does show opposing arrows. Let's see.
There
Are
it
you
is.
seeing it?
Yep.
Yep.
All right. So there's a
Yeah, there we
arrow
go.
pushing it, pointing that way, and the Earth spinning the opposite way.
Yeah, so the Earth spins counterclockwise, and the axial precessional motion is clockwise,
Clockwise and counterclockwise.
which is
Okay.
just why it's interesting. Like, so people in the chat are suggesting, hang the gyroscope or do it on the other side of the planet. Like, I did try hanging it from a string. Again, I'm able to force it to precess in the sense that its axis will go opposite to the spin that I initially give it.
So that must be what's going on with all of the gravitational
Right.
pulls
But it
around.
has to be forced. And after it does a few rotations, you can see it. It immediately loses energy in that rotation, and then it stops, and then the axis begins to rotate in the other direction. And it does that easily and naturally. That may be a function of the bearings, though. You don't know, because there's bearing friction happening with the gyroscope, and I don't know. It's been really interesting playing with it and trying to understand, and then reading about, like, this is interesting. The Earth is supposed to have a precession movement that isn't what we normally see with gyroscopic movement here. So.
Right. So you got the rotation and the revolution in the same counterclockwise direction. And you've got the precessional motion. Now, this would be seen from like the celestial North Pole looking down on the Earth. You would see its rotation on its axis would be counterclockwise, and its revolution about the sun would be counterclockwise.
Yep.
The precessional motion would be clockwise.
Yeah.
Good. We've got that straight. That's a good thing.
Yeah. Okay.
Okay. So why are we even talking about
Well,
this?
because you asked me about the gyroscope, and I was just pointing out that I was having a difficult time making it actually precess like the Earth is supposed to. So that's why we were talking about that. But we can move on.
Okay. Well, I mean, here we are. It's the 20th. I haven't even I've been remiss. I've not looked up to see the exact moment of the solstice. Have you, Kyle? The exact moment? I don't think we've hit that moment yet. But it would be appropriate if it actually happened while we're having the podcast here. Wouldn't that be something? We'd have to stop.
I think somebody could find that real fast.
Yeah, Kyle can find
I'm
it.
looking.
Yeah, we'll do. We're at Eastern Standard Time here. Brad, Mike, and myself, and the Brothers of the Serpent are at what, Central Time?
Yep, we're at Central.
Yeah. So they're an hour behind us. We are actually 1 hour in their future at this moment.
That's right. That's right. You're farther into the counterclockwise spin of the Earth than we are.
Yes.
Yeah.
Yeah, I had
Can this be
to
right?
shut down the live stream on the YouTube channel. Is there? I saw it, but yeah, I got concerned that I was going to get consumed into some time warp myself. Start spinning or something,
Oh, yeah.
or processing. So yeah,
Well, it's saying
it's on. It's good. We're live.
this random
Can we start now?
website, time and date, says that the winter solstice in the northern hemisphere, 2021, is Tuesday, December 21st at 9:59 a.m. Central Standard Time.
Okay, so the actual moment then is tomorrow morning.
Yeah.
12 hours and 12 minutes away.
Yeah, so we're getting up close to it. So really, we're not even in the same day. This is typical. 21st of December will be the solstice. And Mike, what does solstice mean? There's
Mike?
an awkward silence.
Oh, his
descends over
mic's
the
not
team.
working.
Oh, his
Your
mic
mic
isn't
is not working,
Yeah.
Mike.
Mike, Mike is live with us.
Oh, yeah, sorry.
There
I
it
forgot
is.
to press the mic button. Solstice.
Soul, ask Kyle what his son's name is.
Soul.
Stis.
Yes.
He didn't have his headphones on when before the show, did he?
Yeah.
Yeah.
Is it like sun stop? I don't know.
So, yeah, basically the sun stops. The
Okay.
Sun
stands
stasis.
still.
Stand still.
Stasis.
Stasis. Okay.
Stis.
Exactly. So, what's happening, and we'll pull up a horizon, a graphic of a horizon calendar here shortly, so you can see this. But it has to do with, from our vantage point, that oscillation on the horizon, back and forth. Because at equinox, the sun rises more or less due east. It's always going to be a little bit off, depending on your latitude. You'd have to be right on the equator to see it, and you'd have to be at the right position in the rotation of the Earth to see it. Precise to rise dead east. And of course, what's happened is, by the time you get, 9 hours later, whatever the length of the day cycle is, and it's setting, well, the Earth has already moved. See, it's already past that moment, that point in space, that mere point that we talked about I think in one of our last podcasts about the equinox being this mere moment. So winter solstice now this is all going to be from the perspective of the northern hemisphere. The rising and setting positions of the sun on the horizon are going to be shifting further and further south until they reach the solstice. Once they've reached the solstice, then it pauses there for a few days, or appears to anyway, and then it reverses direction and comes back. As it approaches that point, it's the speed with which it's moving is slowing down the whole time until it just comes finally to a stop, hesitates, and then starts coming back again. And then it's speeding up all the way up until it gets to the equinox, at which point it's moving the fastest. It'll displace the greatest amount of distance along the horizon. And then again, it'll be slowing down as you get to the summer solstice. So it's this oscillation back and forth. And it's a rhythm, and it's been going on for a very long time. And it always was very important to ancient peoples.
Yeah.
For some reason, to track that motion. And as we'll see, that the ability to track that motion was embedded into the design of all kinds of ancient structures. Single
That gives us
structures,
the
and also
seasons.
actually layouts of whole communities were based around the lines that could be traced upon the earth of this celestial motion. The question is why would they do that? Why were they so interested in tracking this motion? So let's see here if I've got something we can look at here.
My thought is that, growing up in this modern, technologically advanced society where we were taught the mechanics of the solar system before we had the chance to be taught, like, hey, get up and observe the rising and the rising position of the sun or the setting position of the sun every day through an entire year. And
that's kind of what you need to do.
That's what I'm trying to say, is that we grew up learning about the mechanics of the system without what you experience, in direct observation of the system from our position. So it's kind of strange, like, you know what I'm trying to say? Like, looking at how they may have what they may have thought about it, when the possibility is that they were just observing this stuff from here, having no idea of the mechanics of it.
Mhm.
And you're seeing this motion over the course of the year and finally noticing that and seeing the pattern that
So
that
the
might.
challenge to us is to put those two models together
That's right.
so that we can visualize what's happening, in a sense on the macro scale sense, as if we were standing outside watching the whole process
Right.
from, the standpoint of the aliens or somebody, or the angels, however you choose to think of them, as compared to what we see down here below on Earth. So let's do, let's just go ahead and start with this. And
Oh, yes.
this is a good one.
Yeah.
It's a good graphic here. So this is what, I suggest that everybody does this every night for 1 year. Go out and draw a big circle in the ground, and put a cross in it, and then put a chair out there, and, make sure it's a comfortable chair. And then every night go out there and sit there from sundown to sun up. So, and then this is what you'll see. You'll notice here, you've got the solstices, the winter solstice, equinox, the summer solstice. You've got the zenith. Remember, the zenith is defined as the point directly overhead from your vantage point. It's different than the celestial North Pole, and it's this axis here that is moving because of the precessional motion of the Earth's axis. But so what happens is that on the summer solstice, which would be 6 months away from where we're at right now, because the Earth is tilted, its northern hemisphere is tilted towards the sun, the angle is different. So it creates the longest time that the sun would be above the horizon. So you can see why a day would be longer on some. This is the longest day of the year, and this is the shortest day of the year, right? And this is where we're at now. We're at the shortest day of the year. Notice that they put the galaxy is in here. I guess this, or is that, I don't know, maybe that's just an artistic effect. And then the equinox, there'll be two equinoxes, and they'll be the same. And they're right in the middle of the two. They're right in the middle, between the winter solstice and the summer solstice, or very close to it. And then if we go to here, we can see another way of visualizing it. And here you have the terrestrial equator, which is the red line, and the white line is the plane of the ecliptic. So the white line is the orbital plane of the Earth, and the red line is the Earth's equator projected into space. And so it's obvious that you can see from this diagram, rotating this way. So from above, if you were up here, see vertical of the ecliptic, if you're looking down, now that motion is clockwise, right? But then the Earth's motion is going to be the opposite of that. But so what's happening here is this full circle takes just under 26,000 years. If the people listening had seen some of our preliminary podcasts on the great year, we did talk about this.
Yep.
So it's going around, and the tilt of the Earth's axis is 23.5 degrees out of vertical from its perpendicularity to its orbital plane. See, and the orientation, that tilt we can assume stays relatively constant, although the obliquity of the ecliptic, which is one of the Milankovitch elements in the three different elements that combine presumably to affect Earth's climate. The Milankovitch, basically what that does is it factors some things together, and it's too complicated to get into right now, but it actually comes up with a shorter period. But when you extract it from those other elements, then you've got the just under 25,000 years.
A shorter period for the entire precession. Is that what you're saying? Like when you factor in the Milankovitch cycles, you get shorter than 25,920.
Yes, you do.
Okay.
Yes. So here you're going counterclockwise, and the tilt of what I'm getting at is that the tilt of 23.5 degrees varies somewhat. So that sometimes it's a little bit less and sometimes it's a little bit more. That's the obliquity of the ecliptic. But for all practical purposes, for right now, we're 23.5 degrees out of perpendicular. And when we say perpendicular, that's the Earth's axis to the Earth's orbital plane. So in other words, Earth going around the sun sweeps out a plane, and its tilt is 23.5 degrees out of perpendicular. And so what that means is that relative to like this orange dashed line here, the vertical of the ecliptic, you'd add 23.5, and you get 47 degrees, defines this angle, right? So right now it's this line here that points up, as it says, direction of the celestial North Pole. And right now there's a star, a prominent star that's very close to that position in the sky, Polaris. And so we use that as one of our guide stars. It's, you know, the North Star, as it's called, or Polaris. But you can picture that this yellow line is hinged to this red line, and that they're attached to one another. So this red line, we're looking basically at a plane, a two-dimensional figure in cross section. So all we see is the line, but it's in reality, you know, it's a vast plane. Think of like an old-fashioned 33 RPM record album with a dowel stuck through the hole in the middle. So as you rotated the dowel, the record album is going to be moving with it, isn't it? Right? I wish I had brought.
Yep. Perfectly clear.
Yeah, I think you can visualize that. So what that's doing, whoops. What did I do? Sorry about that. Let me just, there we go. I bumped the.
Nope. Bumped it way ahead or way behind.
Went to Australia.
Are we still?
Yeah, we see it. We see your
good.
screen there.
All right. Good. Okay, so get back to there. There we go. So that red line is the cross section of a disk that is also moving in tandem with the axis of the Earth. And so the plane of the Earth's orbit remains fixed. The celestial equator moves. And so the intersection point, the line of intersection between those two planes, is moving at the same rate. So let's go to this graphic. And here you see the vernal point, sun at the spring equinox, right? And you come across here and you've got Pisces and Aries right there. Pisces. Let's see, we're over here, sun at autumnal equinox, sun at summer. Here we go, down here. So sun at winter solstice. There it is down there. And so here you see the green line is the celestial equator. Here's the Earth. Project its equator into space, and that gives us the green line, right? And the zodiac is the yellow line, or the plane of the Earth's ecliptic. So this is the yellow line is the Earth's orbital plane. The green line is the Earth's equator projected into space. So you can see here where they intersect, right? So as this moves around, this cross with a solstitial line and an equinoctial line is moving, and it's moving along the celestial equator. Does that make sense? I know it's hard to, that's why we need
this is a
animations.
This is a strange graphic because it's trying to show you the overview, but trying to also remain geocentric, which is weird. Right?
Yeah.
We've got 4 suns in this picture instead of showing multiple positions of the Earth. Like a heliocentric model. But yeah, I see what it's pointing out.
Right. Well, what you can
How
see
do you know
here
it's not a
is the
geocentric?
equinox, the sun is right there occupying the intersection of the two planes. Whereas like at winter solstice, you'll see there's a 23, actually later saying here, 23.44 degrees south, you'd say, celestial latitude south of the equator, celestial equator. Just the opposite at summer solstice. It's above it.
Yeah.
See, because of that tilt. And see, that's why we have the seasonal changes. If the Earth's axis was vertical, to its orbital plane, you wouldn't have seasonal changes like we do now, because it's the tilt that causes the seasonal changes. And what you would then have is, the change would be
It would be due to
dependent upon
Milankovitch.
latitude.
Yeah.
And you would probably have basically desert at the equator, because it's going to be constantly under direct sun. And then you would have constant night darkness at the two poles. And then somewhere in between, you would have presumably some habitable, but I don't know, things would be so different that it's hard to say. But, you can do a quick thought exercise, and basically there would be no seasonal change without that tilt. And here's kind of a much simpler version of it. Again, here you can kind of see with this, here's the Earth's equator, this dashed line. If you project that into space, it gives you the celestial equator, right? And so as the Earth's axis is moving, so is its equator. And if it's the Earth's equator, terrestrial equator is moving, then so is its celestial counterpart. And so because it's moving, then it's making this motion along this motion of the intersection points. So the intersection points gives us the equinoxes. And then when you come 90 degrees around, right, or all the way around 270 degrees, then what happens is you've got the maximum difference between these two, right? Does that make sense, sort of?
Yeah, another way I think of it is the solstices are when the line that you can extend from the axis of the Earth intersects the axis of the sun. Those are solstices.
Okay.
You see what I mean?
Say that again.
The axial line of the Earth that if you imagine you could extend that out into space, it's got a tilt to it, right?
Yeah.
And then there's an axial line you can draw for the sun, which is basically straight up and down for the solar system.
Okay. Yeah.
When the axis line of the Earth intersects the axis line of the sun, that's a solstice. And 90 degrees from that in either direction are the equinoxes. Is that not? Yeah. Is that weird? That's how I think of it.
I'm trying to envision what you're saying.
That's all right.
Have some...
But I understand what you're saying. It's like, to me, you're looking at it like from a geometry standpoint. You're watching. In your mind, you've got the geometry of these two planes in motion. You're seeing the correlation between the intersecting lines of the two planes being your equinoxes. I get that. And also, yeah, like it's kind of the same thing with the axial line.
Because on the summer solstice for the northern hemisphere, the tilt of the Earth is pointing basically directly at the sun, which would make the axial line of the sun intersect the axis of the sun. The axis of the Earth intersect the axial line of the sun. They would make an angle way above the solar system somewhere.
Well, yeah. Okay. Now, I see now what you're saying.
Yeah.
Okay. When you put it that way.
Right. That's probably a better way to say it. But yes, the solstices are when those axis lines intersect somewhere in space.
And the equinoxes are when the equatorial and ecliptical plane intersect.
Yeah, that's right.
So it's like you have that's an interesting. That's cool.
Yeah.
Well, it's challenging, but it's worth. I think it's worth trying to understand.
I agree. We've spent
Well,
spent a lot of hours.
The need to get out
trying to
and
figure this
watch and see
Absolutely.
the changes in the motions, and I'm certainly guilty of not doing enough of that. As much as I love it, I'm still questioning the motions, and I don't see it often enough. I got lost in my own thought exercise there. Not to throw you too far off, but seeing for the last month or more, right? You got Jupiter and Venus and Saturn that have been visible, in a line.
Yeah.
Yep.
So you can like see the arc of the plane of the ecliptic, right?
That's right.
Yeah.
So does that move though with the seasons, or does that stay constant?
It moves north and south.
Yeah.
That line, like if you're looking to the south, it's like that line goes up or down depending on what time of year it is.
It will oscillate
Right.
up and down by basically 47 degrees.
The 47 degrees.
Yeah.
Yep. Yep. I was almost getting there. You guys got me there. All right.
So let's look at some examples. Let's see if I got some good examples here of.
Hey, and we're going to have some
Yeah,
dark skies in Montana for June.
Oh, yeah.
So we'll be out at night.
William, we're working on good animations. It's upside down over there in
Yeah.
Australia.
Australia, we
It's-
need a completely different animation.
Yeah, just if we make one, just turn it upside down.
Flip it.
Okay. Let's see some good examples here. Yeah, here we go. We'll start with this right here. Sorry.
All the things that I edit out in the non-live
Yeah,
version,
that's
right?
fine.
Hey, man, it's
Yep.
that's what you get.
There we
Yep.
I'm having a beer.
Yeah.
Cheers,
This is
y'all.
real. This is real time.
Okay. Simple pole in the ground is where it would start. And the shadows, the angles made by the shadows are going to be dependent upon the latitude, the distance away from the equator. But actually, this is all you need, this in a circle, in order to plot all the celestial movements, at least the ones, visible from the human perspective on Earth. So if you were going to, you wanted to be able to determine the solstices and the equinoxes, you don't need to erect monumental architectural structures to do so. A simple pole in the ground will give you what you need. You can find the solstices and the equinoxes from just tracing a circle around a pole. And like you said, if you had 1 year of observations, you could easily get all of those alignments with a high degree of accuracy. So now here, if we start looking at some of the examples, now these are just a few. I mean, there are many, many examples, and I just pulled a few together here to kind of show people. This is one of the more famous ones. Now this is summer solstice, of course, so this is the opposite of where we're at now. This would be 6 months later, but you're looking along the axial line of Stonehenge, and then you've got this outlier stone here, which is the heel stone, it's called. And when you draw the axis through Stonehenge, through the heel stone, and the point on the horizon more or less demarcates the rising position of the sun on summer solstice. So that pretty much, that was the axis of the monument. So this axis was determined, and then the monument was built around that axis. Now there's actually a lot more celestial alignments in the layout of this, but we're just going to focus on the solstices. And this is Fort Ancient. Now this is relative to our time of year because this is your winter solstice sunrise. And you can see this is Fort Ancient it's a vast earthwork complex. And when you stand at the center of the structure and look to the east, of course, it's not exactly to the east. It's going to be south of east. You have this notch in the hill here, and the notch perfectly lines up with that position of the sunrise. And so this is, in each day, what'll happen now as you're facing this is that the days and then the weeks come after the solstice, you'll see the sun moving back to the north, and then it'll hit the equinox, and then it'll come back to the south, and then once a year it's here. And so they were obviously commemorating that moment.
Is that contemporary with Serpent Mound?
I don't know. It's Serpent Mound actually is, I think, been some new dating on it that suggests it's much older, or at least somewhat older than the previous dates, which really isn't surprising at all. Okay, so let's go to the next one. Okay, so Casa Rinconada in Chaco Canyon, New Mexico. an aerial view. Let's actually, I think I have a, yeah, so there's a summer solstice sunrise alignment at Casa Rinconada. There's a slot. And let's see, do I have it here? Yes, okay. So here you see what it says solstice niche E right here. You've got these small upper niches, but then this particular one here, you'll notice how it's larger. And there's a window, and on the morning, that's this window that you see right here. And then um, on the summer solstice, the sun ray will shine through there and it will illuminate this notch or niche, sorry, right here. Let's see. Now I've got another one. I think you can probably I've got photographs of this, but I was not here on the summer solstice, so I don't have photographs of the actual event. But I know there's some people have made those photographs and put them online. Maybe Brad, you could possibly grab one of those. Let's see. I could probably have another. Let's see here.
What is Brad? Brad has pictures of it. Is that what you're saying?
There are pictures online.
Oh, online. Okay.
Online. Let's see here. Okay. Yeah, I've gotten now. This is a different presentation. This is the presentation on the Chaco and culture, but I actually have a little bit more, additional slides that will help to clarify how this thing is laid out. So here's this overview again. Then we have this diagram. So if you look carefully, this is from a book, Astronomy and Ceremony in the Prehistoric Southwest, edited by John B. Carlson. Here's the sun rising on the summer solstice. So this is going to be, as far north as it's going to rise in the east. And then a ray of light comes through this window and illuminates the niche on the opposite side. So there must have been, I'm guessing, some type of an effigy or something that was probably placed in that niche that was illuminated by the ray of the sun that morning. I've done an overview here so you can kind of see here's the window, and here are the elements of the various structure. Here you'll see the sun out here, and then there's the sun's ray coming in like that. So it does this, summer solstice, and does this one morning of the year. It's exactly lined up. So this is obviously not a coincidence. They clearly meant to enshrine this moment in the structure of Casa Rinconada. And of course, the whole of Chaco Canyon, we are now figuring out, is part of a gigantic astronomical complex that has not yielded up all of its secrets yet. But you can see there so there it is on that morning. And I believe that they allow people in there to witness this. That'd be something we should do.
Oh, yeah. So is it just a solstice alignment for the summer? There isn't an equinox or a winter alignment there?
I haven't seen anything about the winter, but if you look here's examples of astronomical alignments in Chaco Canyon after Anna Sofaer's work in 1997. And like I said, the whole canyon is, the whole infrastructure is laid out astronomically. It's like a large astronomical observatory, and it's got lunar as well as solar alignments in it. See, so here you've got the sun, you got the moon. Here's this moon alignment coming along here, and that moon alignment, let's see if I've got it here. Yeah, so this is the lunar wall alignment at Pueblo, Benito. And then what happens is the moon rises right along that alignment. And that's what she's showing here. So Pueblo Benito is oriented and placed along this line alignment right here that runs through the whole canyon. So, and if you look down here, here's the built-in alignments. You've got solstice alignments here. you've got lunar alignments, and the whole complex is laid out to enshrine those events. So that's very interesting to me that they would do that.
Yeah, how long did they wander around to find a canyon that was oriented just specifically like that?
Well, that's a good question. I don't know. There's mysteries piled upon mysteries. So let's see. I think I had a few more here. Let's see. We had Casa Rinconada. Oh, yes. And then Serpent Mound. This is a great graphic on the website moon at serpentmound.org. But this is showing that the egg in the serpent's mouth, its axis is oriented to the summer solstice sunset. But then the coils, the axis of the coils, you'll hear here, summer solstice rise, winter solstice rise, spring equinox rise.
Oh, you might need to share that screen with us, Randall.
Well, that would help, wouldn't
Yeah,
it?
that would help.
Let's see. Sorry.
No problem.
Sorry.
No problem.
All right.
There we go.
There we go. Okay. Participants can now see your application. Good. Okay, so you got a summer solstice sunset defining the axis of the mouth and the long axis of the egg, the elliptical feature there. And then the coils define the two solstices and the equinoxes. So if you draw an axis like this from this central point, and, you know, it'd be interesting to go. I've been there, 2 to 3 times now, I guess. To find that point, that viewpoint. I wonder if there's anything there. But if you look out this way, the axis of this coil defines the summer solstice. The axis of this coil defines the winter solstice. And this is your going to be your due east-west right here. And here's your north-south line. So it looks like Serpent Mound is another astronomical type of observatory.
Doesn't it also have lunar alignments?
Yes, there are lunar alignments. I couldn't tell you exactly right now what they are.
I remember seeing a diagram that showed similar lines like that, but it was, I think it was the minimum and maximum
Lunar
standstills.
In Serpent Mound.
I think so. I'll have to look it up. Or it was minimum north rise, maximum north rise, that sort of thing. But I thought it was of the moon. I'll have to check it out.
All right. So here's a photograph looking along the axis of the egg, and there's the summer solstice sun setting in the west, defining that alignment. And then here's the Etowah Mounds, Cartersville, Georgia. You got a summer solstice sun rise alignment, and it's defined by these two mounds right here. This is mound A, the big one, mounds B and C, and that alignment right there. And I don't know if you can still see it, but maybe 25 years ago, when first few times I visited here, there was still a visible depression in the very center of this mound, which I guessed probably held some kind of a foresight pole, something that was there. And then that lined up on the distant horizon. There was 2 hills that kind of created a V. So when you projected this line here, it towards the east to the northeast, then you would see the sun rising between those 2 hills.
Yeah.
If that makes sense. And then you've got a winter solstice sunrise alignment at Newgrange, Ireland, right? And I think we've got a graphic here to show that, Newgrange, Ireland. So when you project out through the entry tunnel, it's lined up with that same position. Interestingly, so think about this. I presume that there was some kind of a ceremony going on. Obviously, they wouldn't build a structure and put an alignment in here and then not be out there present witnessing this particular morning. with some type of a ceremony. But what's interesting is you've got this event happening here in Ireland, and then jumping back, you have this happening the same morning on the other side of the world, or at least a third of the way around the world.
Yeah.
So you've got two completely disparate cultures, geographically removed from one another, but they're both observing this same event by utilizing these structures to do so. And then you've got Bighorn Medicine Wheel. Check this out. So you've got the axis of that goes right to the summer solstice. So as you're facing here, now the summer solstice sun is rising in the northeast. So it's going to have, if you had been watching this in the weeks leading or months, leading up to this, you would see each morning the sun rising over the hills, and then on the morning of summer solstice, it'll rise right here, and then it'll pause here. You'll probably actually see it rising at this point on the horizon several days in a row. And then it'll start migrating back along the horizon this way. Then you've got, of course, the famous alignment at Chichen Itza, which is a spring equinox, sunrise alignment. And you can see as the sun is rising, it would be off, to the right here, shining across the stepped platform here, throws this play of light and shadow on the balustrade. So you can picture as the sun is rising, these coils of light are descending the balustrade. They're moving down. And then at the bottom, you've got the serpent. So this represents the serpent, Kukulkan. So this was a pretty elaborate construction, and clearly this had to have been thought through. This was not something that just happened by coincidence. I'm sure it was planned into it right from the beginning. So, and then at Teotihuacan, there's also alignments. We could get into it. Summer solstice Chartres Cathedral. This is a really interesting alignment here. Here's the layout of the cathedral, right? And what I'm going to do is I'm going to show the sun over here, where the position of the sun at high noon. And you've got these two buttresses here with a window in between them. And on this one day of the summer solstice at high noon, the sun is high enough in the northern sky that a ray of light can actually pass between these two buttresses and then pass through the stained glass window and enter into the interior of the cathedral. And if you stand at the interior and look up towards that window, which, as it says here, dedicated to Saint Apollinaire, who was a Christian saint. And of course, that is a hint right there, that it has something to do with the sun. Take a look right up here. Right there, there's a little clear niche in the window right there. And so when that sun strikes the window, a ray of light will come through that niche, that little clear chink of perfectly clear glass, and it will shine through. A ray of light will come down, and then on the floor of the cathedral, right there, right near where the transept crosses the nave, there's a very obvious tile that's been set aslant to the others and is larger and is a different type of stone, so that it stands out very clearly and then very conspicuously. And then right there's a little metal tenon on that tile, right? So at the moment of high noon, summer solstice, that ray of light coming through the window strikes that tenon.
Wow,
that's pretty wild.
That's pretty cool.
I would say that's very cool. So, we find over and over again this interest in these celestial movements. And I think a lot of people now know this, but for a long time, it was not really appreciated by people that the Great Pyramid had an indentation, had indentations in its side. It's actually not four-sided, it's eight-sided. See, look at it. And here it shows up, but it only shows up like this when the sun is basically due east. So this is a photograph taken at 6 p.m. on the day of the equinox by the Royal Air Force. So the sun is setting over here in the west, shining, and you see the shadow, and the line of the shadow lines up here. And then you can see that there's this very shallow but very distinct inset in the geometry of the pyramid. That would have been, I'm sure much actually more obvious when the casing stones were still on there. So again, this is a phenomenon that just shows up on the equinoxes.
Just as an aside, one thing that struck me about the pyramids when we were there recently in October was when you're standing, the entrance is on the north side, on the northern face. So when you're standing out there looking at the entrance, the pyramid is on the southern sky. The southern sky is right behind it.
Yeah.
When you're looking at the entrance. And so when we came out in the evening time, out of the entrance and came down onto the the platform below and looked back, it's like you could see the planets in this arc going over, right over the peak too.
Yeah.
Yeah.
When you're standing at a certain position. And I don't know, for some reason that struck me. Like, wow, it's just like a big pointer.
Yeah. Like an arrow.
And, for
arrowhead pointing.
Yeah. That's pretty cool.
Yeah, that is very cool. And then look at this next slide here. This is, your summer solstice sunrise as seen from the Sphinx. Now, you can't tell me that this is just accidental.
Okay, that's cool.
Yeah. Right between them.
So the Sphinx is looking directly at this position. This, again, summer solstice. So this is that most northerly position.
Well, I think the Sphinx would be looking, right? No, that's the sunrise. How is that right?
Yeah, it wouldn't be looking through the pyramids. That'd be
the Sphinx should be looking the other way. So
east.
Maybe that's a sunset.
That must be a sunset.
Oh, this must be sunset.
So, yeah.
Yes. Sorry.
Yeah.
Sorry,
so if the picture was taken from the Sphinx, they're looking the opposite direction that the Sphinx is to see that.
Right.
Yeah. Still very cool.
Okay. And
as seen from the Sphinx is
Yeah.
what the picture says.
Right.
Yeah, but
Not. Yeah.
yeah, that must be a sunset,
it's seen
though.
from the Sphinx.
Right.
Yeah. So, you find this phenomena all over, and I think it raises some interesting questions about what the motives were. And it'd be one thing to find a culture that, was obsessed with the sky and these celestial movements, but it was like all the ancient cultures this was one consistent theme that seemed to unite all these various cultures all over the world. And we find the stuff in some of the very earliest examples from, ancient Egypt and other ancient cultures. We can look and see. I don't have it handy. Maybe I can pull it up here if we take a little break. Some of the alignments of a lot of the monumental earthwork structures of North America are, Newark is a good example of where there are multiple celestial alignments incorporated into its ground plan. And to me, it raises questions of why were ancient peoples so interested in this that they obviously in some of these cases went to great efforts. Fort Ancient, that's a massive complex of an enormous amount of earth that had to be moved and piled up, and then not just randomly, but set out in such a way that it enshrines these alignments. So that to me is a question worth pondering and trying to actually come to some kind of a conclusion, some kind of at least some kind of a working hypothesis of how this phenomena could come about.
Well, they're at the very least, you could say there were many ancient cultures were very interested in celestial movements, and
Yeah.
they aspired some kind of importance to them and encoded them in their structures in various ways. What they thought those movements meant is a big question.
Right.
Yeah.
But for some reason, they seem to really want to track that motion. And why they wanted to do that's a good question. But, right now, let's see if I can get this up here going.
So-
Well, you mentioned a break, but we're live, so can't take a break.
We're
Well,
not allowed to take breaks.
Not allowed. No breaks allowed.
We'll just
No
let
breaks
Mike
allowed.
tell a story. And we'll go take a break.
By the way,
Well,
someone unseen, thanks for the super chat.
Oh, yeah.
Appreciate it. Merry Christmas.
Merry Christmas to Sydney. Yeah, thank you.
No, that's Sydney, Australia.
Yeah, to Sydney, Australia. Merry Christmas to you as well in Sydney. And there was another super chat before that from T. It was just
Thanks for
one,
the super chats.
yeah, it was
Much
one
appreciated.
letter. I should
Appreciate you.
remember it. Yeah.
I don't see it.
So yeah, it's kind of a, just a timing reference point though. I mean, at its basics though, right? To know when your seasons are going to change. And I guess that's the basic thing most people would point at, that they were trying to decide when they need to harvest and when they need to plant and that kind of thing.
Well, that was why I started with showing, the pole in the ground, because that's really all you need. You can figure out all of those things with just a stick in the ground
With
and
your
a
pole.
circle scratched around it.
Okay.
You don't need to, erect huge structures of earth or stone. You don't need to erect monumental architecture to be able to determine that. That's all you need is a. So I think it had to go beyond. I mean, once it's done, of course, yeah. I mean, it could be used for that clearly.
So
but-
what do you think about this? Is coming from the chat. What do you think about the idea that they were using this to track for agricultural reasons?
Well, that's my point. You don't need. You can use it obviously, but all you need again is the stick in the earth with a circle drawn around it. And with that, you can lay these things out. You simply draw a circle, you put a stick in the ground, you draw a circle around it. And over a period of 1 year, you can get all those alignments. And you don't need to build anything really, except have you could lay out a ring of, look at the medicine wheel. Now that's a pretty, it still took some effort, but you could build just anything. It could be, you could put sticks in the ground to mark those alignments. In other words, picture back to the circle that you had of the guy sitting on the chair. You've got that circle and you're just watching, where's the sun rising on the horizon on summer solstice, and you mark that alignment because and it's easy to do because look, when the sun is rising, you've got the shadow in the opposite direction that's creating that alignment, right? And the same thing is happening at sunset. So all you need to do is maximum 1 year, and you can get the rising points on the horizon, the setting points on the horizon, of the solstices, the equinoxes, and again, that's all you need. You don't need to build huge structures of stone and earth. There had to have been some other reason on top of that, because if their whole motive was just to determine the seasons change, you don't need that. So
Yeah.
I mean, and I would think that if that was the primary motive of all of these ancient cultures, because they're primarily agricultural, we wouldn't necessarily find this consistency of they're building these extraordinarily complex and large structures to enshrine those particular alignments. Because again, all you need is a stick in the ground and a circle and 1 year's worth of observations, and you got it. And then all you have to do is maintain that, and make a little adjustments for, over every couple of generations, you might have to make a slight adjustment, but then that's all you'd need. So
Maybe they just had to occupy the population during the non-growing season.
well, okay, so let's assume that's the case. All right. So that all the cultures, they all come up with this. Hey, we're gonna build this giant earth mound at Newgrange. We're going to set up Stonehenge and organize, presumably hundreds, if not thousands of people to cut and transport stones. And you're going to get astronomers out there. You're going to have this gigantic social enterprise to pull this off. and ancient cultures are doing this all over the planet, right? You'd think somebody would stand up and go, wait a second, if we just need to know the seasons, guys, it's going to be a whole lot cheaper just to put a effing stick in the ground,
Right.
okay?
Which they also would have already had to do to understand how to build Stonehenge in the first place.
Sure.
Right?
But
Yeah.
then some guy's like, I want a bigger stick.
Yeah. That stick
Well-
sucks. I need a giant rock.
And this brings up to mind Göbekli Tepe. I mean, with Stonehenge, you've got a singular structure, but at Göbekli Tepe, and we discovered another one nearby. I've forgotten the name of it, but it's near Göbekli Tepe, the same kind of structures.
Right.
Multiple of these circles and megaliths, and they were built deliberately, and apparently, from the things I've read about it, agricultural communities grew up around these to service the builders of these things. So they're real puzzled as to, it's sort of a chicken and egg situation with why, did they have the agricultural community to support the builders, or the builders, did they do this because they had excess labor from being agricultural?
Yeah.
Well, I would say both. I mean, obviously they had to be agricultural. I mean, because you got all these people working on this, they had to eat. Right. And
Absolutely.
so I think if they're working on this, they're not going to be engaged in growing food. So you have to have some division of labor in the society, obviously, to pull something like this off. And I don't think it's a matter of just, hey, let's do this in our spare time, because I'm sure that there are plenty of other things that they could have been doing in their spare time that would have more directly impacted their survival as a tribe, as a community, or whatever, than building some, ostentatious big old monument. In other words, hey, you got the Eastern Woodlands people, and they're, they've, if they're practicing agriculture at all, it's just a form of subsistence agriculture. But then they've got their spare time. Does it make sense that they're going to build these huge structures with astronomical alignments, elaborate astronomical alignments in them? And I just have to keep coming back around it that there had to be some other motive on top of whatever the day-to-day practical usage of such a thing was. There had to be some other motive, and it had to be something that was consistent, because, hey, I think it'd be fair enough to say, yeah, there's one of these outlier cultures that for whatever reason was obsessed, and so they really had to do this thing. But and then you could basically explain it away. But when you have a dozen cultures or more, dozens of cultures all over the ancient world doing the same damn thing, you got to ask, okay, there's something more here than meets the eye. And what is it? It's not just to determine the seasons.
Yeah, I agree. It seems like there's the effort involved makes it seem like there was more to it than just that.
Yes.
Yeah.
Now, maybe a hint what that would be.
Also, we want to thank Andrea Clark Martin for the super chat, and also Slowboat. And there was one
I think we know Slowboat.
We know
I think he
Slowboat?
came to the Scablands
Oh,
or one of the trips, or maybe it
Sounds
was
familiar.
Matheson.
Thank you. Thank you.
And Alfie Grimes.
Alfie.
Appreciate it.
Okay, so
Well, okay, you were going to hint at something, so I'm not going to guess then. So if you're going to go ahead.
so let's dive into some of the astronomy here.
Give us your best guess,
let
Brad.
me pull up. Again, let me grab my share screen here, and we'll do this. So here's your coordinate systems that are
Thomas,
in
thanks a
use.
lot.
What's that?
We're just thanking people for the super chats. Go ahead, keep going.
Oh, okay. So you've got basically four systems. So the horizon or altitude azimuth system, and this is the thing that would be most closest to an observer on the ground. Like if you walk out at night and look at the night sky, or if you were, somebody 4,000 years ago looking at the night sky. The reference plane is just simply the local horizon. It's measured by altitude above the horizon or below, and the azimuth is going to be the direction clockwise from due north. And it's used for, as it says, celestial observation relative to a local reference point. Okay, then as you move out from that, you come to the ecliptic. The ecliptic, which is Earth's orbital plane, is measured by ecliptic longitude and ecliptic latitude in degrees. And this is primarily used for describing the motion of planets, comets, asteroids, etc. But I think right there might be a clue. Describing the motion of planets, comets, asteroids. Equatorial, celestial equator, measured by your right ascension in hours, minutes, and seconds, declination in degrees, above or below the celestial equator, used primarily for star atlases, objects fixed in the celestial sphere, which of course is your fixed background, which is your reference against which all of this motion is going to be measured. And then finally, you have the galactic system, which is based upon the Milky Way galaxy. The galaxy has its own plane, axial plane. So it gives you galactic longitude and galactic latitude in degrees. This is going to be primarily for objects outside the solar system, stars, star clusters, galaxies, etc., used by modern astronomers, presumably not by ancient peoples, who are going to be presumably not going to be looking at objects outside the solar system. However, when we get to the various alignments, then these various systems with their reference planes become more relevant. So we've seen this. Let's just keep going. Here's a more elaborate description of these. So if you go out and you stand, oops, damn it. Why does it do that?
Also, thanks to Richard Ford for another super chat. Appreciate that.
Yeah, and he says, thanks for all the great lectures there, Randall.
Yeah.
Oh, well, thank you, Richard, for tuning in, man. We appreciate it. Okay, so your horizon system, azimuth is measured in degrees clockwise along the horizon from geographic north. Altitude is measured in degrees above or below the horizon. It locates a position in the sky relative to a specific time and position on the Earth. Altitude, azimuth coordinates change with any change in time or location. The coordinate system, which is most useful for archaeoastronomy. Okay, then you have your ecliptic system, which gives you ecliptic longitude, which is measured eastward along the ecliptic plane. Something's going on here.
Is it Todd the cat walking on the keyboard?
Yeah.
No, unless he's turned invisible. Okay, we'll try this again. Yes, measured eastward along the ecliptic plane from the vernal equinox. Okay, now this is the thing that's moving. It's this vernal equinox that's moving. And so the vernal equinox moves, the autumn equinox is moving, the solstices, they're all moving together. You got to picture that big cosmic cross is rotating, right? Ecliptic latitude is measured north or south from the ecliptic plane at 0 degrees to the north or south ecliptic pole at 90 degrees. It's used to specify the locations of objects orbiting the sun, referenced to Earth's orbital plane, considered the natural coordinates for the solar system. And then you have the equatorial system, which is right ascension and declination, corresponds to terrestrial longitude and latitude. So imagine Earth's latitude and longitude lines projected into the celestial sphere. And that gives you your equatorial system, right? And the 0 point, reference point, would be the celestial equator, right? Right ascension is measured in hours, minutes, and seconds with a full circle of 360 degrees equaling 24 hours. Well, that's because the whole thing is rotating. And we've designated that period one tropical day from a point on the Earth coming around and then coming back to the same position relative to the sun is what we define as a tropical day of 24 hours. We take that period, we divide it into 24 hours, right? Which, as you commented earlier, Kyle, whoever you are, you said earlier about that difference, right? Because what's happened is it comes back around, but the Earth has moved a little bit in the interim, right? and so has the sun. And so it takes a little bit longer for that point to catch up to the sun, which has been moving eastward during that passage of time. So your tropical day, which is measured one rotation relative to the sun, is a little bit different than the sidereal day, which is measured with respect to the fixed backdrop of the stars.
Right.
Right. So the 0 point of right ascension is the vernal equinox.
So the fixed background stars, it's a little bit longer, isn't that right? It takes a little bit longer for example, like the sidereal year is a little longer than the.
We're talking about the sidereal day.
Yeah. Okay.
Sidereal day.
Well, no, it's actually going to be a little shorter.
The day is
because remember,
shorter.
Is it shorter?
The sun has moved, so now you got to go a little bit further around
To get back to the sun. Okay.
to get back to the sun.
Okay.
Equatorial system is aligned with Earth's axis of rotation, but does not rotate, causing the stars specified by the system to remain fixed over the course of a day, used most commonly to specify fixed celestial objects, such as various stars or distant galaxies, or anything that's basically going to be fixed within that, unlike the planets or the moon, comets or asteroids or anything like that. And then finally, the galactic system, which is galactic longitude is measured in degrees from the galactic center in Sagittarius westward along the galactic equator. Galactic latitude is measured north and south from the galactic equator to the north and south galactic poles at plus minus 90 degrees, used primarily for dynamical studies of the macro scale universe. Okay, so with those planes in mind, let me see if I've got some graphics here to help visualize. Okay, so here's this yellow line is the plane of the ecliptic, and this is the celestial equator. And you can see in this particular configuration, the plane of the ecliptic is shown as a vertical line, and the celestial equator you can see has this bit of a curve to it. And the reason for that is because if you extended this off the slide, there's going the celestial equator and the plane of the ecliptic, they intersect, right? And it's those intersection points that are the equinoxes. Well, this is the solstice, and the solstice occurs when there's the maximum distance between those two planes. And you can see here that it's right here at this 18-hour line, right? So this line, check this out, this line, the plane of the ecliptic, and then this green line is the galactic plane, right? Now you'll notice this intersection of those three lines right here. The 18-hour line is relative to the solstice line, right? This is December 21st. I actually did this back, in 2012. To try to show people what the astronomical significance of that particular day was. It shifted a little bit since then. I think by about maybe 7.5 minutes, maybe, of arc in the 9 years since then. But this is high noon at 23.5 degrees south latitude by 45 degrees, 26 minutes west longitude. And what you're seeing here is this alignment. Notice the ecliptic plane, the 18-hour line, the solstitial line, and the galactic plane all intersect in this point right here, right? Now I'm going to jump here to the winter solstice, because this is winter solstice. This is winter solstice of 2012. Now, from our point of view, I'm just using Fort Ancient as an example. We can see that. Let's see here. There we go. There we go. Okay, so that event that's happening now in this epoch, and was pretty much very precise on 2012. We'll see right here. So that's what's going on. So the thing that I want you to try to grasp here is that if you're standing at the center of this and you're looking out through this notch, you've got one line that's leading from the observer here through the center of the sun right into almost basically the center of the galaxy. Now that's pretty cool. You got an alignment between the galactic center, the sun, and the Earth. That's what's happening. And that was pretty much
solstice,
the astronomical significance of what happened on that day. Now, like I said, it's shifted, I think, about 7.5 minutes of arc. So it's a little bit moved because 50 seconds of arc per year. We've got 9 years since then. So 9 times 50 is 450. Divide that by 60. Yeah, 7.5 minutes of arc. So in other words, that position there has moved in the 9 years since 2012, the distance roughly equal to 1/4 of the way across the disk of the full moon.
Now, is that due to precession? That drift?
Due to precession. That's exactly right.
Okay.
That is due to precession.
Yeah.
So basically, what you're seeing right here, it happened. Now it's deviated by 1/4 of the distance across the full moon. And in 25,920 years, it will come full circle and be back here to this alignment again. So that's kind of cool. So now if you're going to, it occurs to me that, if you're going to define a great year, one of the obvious questions is, well, where's the beginning of the great year? Do you have some point that you can say, okay, this is the beginning of it? Does it coincide with 0 degrees Aries, which is, not the great year, it's the tropical year, right? And the sign of Aries is moving along with, because as this precession is going along, it's dragging the 12 signs with it, because the sign of Aries is hinged to or attached to the spring equinox, and the spring equinox is moving, but the constellations aren't. So there's like 2,500 years roughly of motion now that has offset what was originally the sign. If you could go back in a time machine roughly 2,500 years, the vernal equinox is positioned in such a way that, it's between Pisces and Aries. And so now the sign of Aries coincides with the constellation of Aries, but the constellation has remained fixed and the sign has been moving at the same rate as precession. And so that's why now the signs and the constellations don't line up anymore. And they won't line up again for about another, 24,000 years.
But is that just because people is that based on astrology, like the astrological signs? Because if anybody's doing,
that's totally astronomical. Now, see, so that's the difference between tropical. Now, I'm not an astrologer, but that is the difference between tropical astrology and sidereal astrology. Sidereal astrology is going to look at the actual stars,
right? Yeah.
Whereas tropical astrology is going to look at the signs. So, if you're born under a certain sign, that's not necessarily, the sign that's on the horizon, say, for example, isn't going to necessarily be, it's not going to be the same as the constellation. They're going to be offset by, as much as, about 15 degrees or more. More like 30 degrees.
Yeah, we're like, it depends on when the signs were first set.
Yes.
Right.
And so again, that gets back to what I was saying about, where's the exact starting point? Now, from my perspective, you've got to have something that is going to remain fixed over a long period of time. And these rotating solstices and equinoxes every 6,480 years from now, this is going to be the position of spring equinox. And it seems to me that if I was trying to set out some point of demarcation for the great year, the spring equinox lining with the galactic center might work pretty good for that.
Yeah.
Hey, thanks to Gary and Adrian for the super chats also. Appreciate that.
Thanks for the reindeer food.
Yeah, Gary says he's helping to pay for your reindeer
Reindeer feed.
Reindeer feed, Randall.
My reindeer feed. Yeah.
Yeah.
Well, I have been thinking about just chucking it all and becoming a reindeer herder. I think I have a few things to
Tungusi
learn.
tribesman.
So here's a little bit
Now that-
closer look at that whole alignment. I've now rotated it 90 degrees, and I've put in the traditional depiction of Sagittarius and Scorpio. So here now you see the galactic center. Now I think that there's a little bit of variation in where exactly the galactic center could be, but you see that from the standpoint of us, I mean, it's actually, I'm zoomed in here, so it's actually very, very close to this alignment right here. So here's the galactic plane. It would be the local meridian at this moment that defines this 18-hour line right here, which is the maximum difference between the celestial equator and the plane of the ecliptic. And so you can see that all of these lines are converging right here, very, very close, interestingly, to the traditional depiction of Sagittarius, with a little bit of, and I've looked at various traditional depictions, and they're not all exactly the same. There's some variation. And then you can see, though, how closely the point of the arrow of Sagittarius's bow and arrow conforms to that unique point right there, which is the center of the galaxy. The arrow, of course, is pointed right at Scorpio, right over here. So I thought that's interesting. It's almost as if, I bet you, I could even propose a hypothesis that we find some ancient depiction of a traditional Sagittarius where the point of the arrow is aimed directly at the galactic center. Now that would be interesting.
Yeah.
There's probably a name for where the arrow sits on the bow. Is there a name for that? Because it looks like it's real close to that intersection.
Yeah.
More than the point of the arrow. I don't know the name of
Well,
that.
yeah, it does. So maybe, yeah, I don't know. It's just, a lot of things to research here, but it's the whole phenomena to me is just extraordinarily fascinating. And I bet you Dave Matheson would probably have something to say about this.
Yeah, I certainly thought that earlier.
Oh yeah, he would for sure.
Yeah. For people who don't know who he is, Ross, why don't you just
Well, let's get him on one of these.
Yeah,
soon.
we need to get him on one. He would love to
Sure.
sit here and talk
Yeah.
astronomy and ancient mythology with us and the
Mhm.
connection to the constellations and the stars, which is what he does. So Matheson has done a ton of research and drawn a lot of excellent, interesting possible connections between global mythological stories and constellations, and he shows how over and over and over the depictions of certain, whether it's a well-known myth or a very obscure one, the depictions and the descriptions match constellation imagery over and over and over. So
over and over and over.
what exactly that means, Kyle and I are always asking, well, what does it mean, Dave? And he's like, I don't know, guys. I'm just saying.
There's many heroes and
Yes.
gods that are positioned like Hercules or
That's right.
particular constellations.
Even, you can even use like monomyth or the hero with 1,000 faces, that kind of stuff.
And he's got quite a few books, and some of them are great big ones. So
yes,
he
enormous
put a lot of research
tomes.
into it.
That's
And,
right.
Yeah, his website is not coming to mind right away. It's Star Myth. You guys come up with, we need to find that because well, now we got some questions. We'll definitely have to get him on. It's like, okay, Dave, we got started. You got to walk us through here.
Yeah, that would be good. Also got another super chat from NGC 6543, which is in that
Cat's Eye Nebula.
Cat's Eye Nebula catalog number. Says
Nice.
Randall has the best beard in the universe. So there you go, Randall.
Wow,
Thanks
that's
for the
quite a
super chat.
distinction. I need a trophy or something.
Well, you got the super chat. There you go.
I need the
Okay.
mileage on the ship that he toured the universe in.
Yep. Well, we're coming up to the end here of the live stream.
90 minutes.
Yeah.
Right on it.
Exactly right on it. So
That was a quick 90 minutes.
yeah, well,
Always.
It's always
Okay.
good. Mike, what do you think?
It was an interesting session.
You think Randall's totally wrong? I think we should just
No,
he's
I
completely
don't-
right. That's
don't
why
think
you've been
Randall's totally
quiet,
wrong.
because you're like, I don't agree with any of this stuff.
Well, I'll say what my guess is, but then Randall did kind of hint at it that
Okay.
there were, possibly
Oh yeah, yeah. Go ahead
orbits
for that.
orbits
Yeah.
of other things coming around that would be on a longer time scale. So that's what I was gonna, prognosticate maybe. If that's an annual marker, right? And then that helps them track things like then they got larger cycles like out at Chimney Rock, right? They're tracking the 18.3 or 18.6 year moon cycle, right? So then maybe there's got to be larger cycles that
Well,
if
yeah,
there's some deviation off of that annual
we're talking about
spot.
precession of the Earth. We're talking about the rotation of the solar system. The solar system rotates within the galaxy. The galaxy
Yeah.
rotates. We're
Much
talking about
bigger cycles.
cycles upon cycles upon cycles. It's almost metaphysical there.
Yeah.
Almost. I
Since you
agree.
mentioned Chimney Rock, go ahead and pull up.
Now we got it. And while you're pulling that up, we got another super chat from Adrian. Dark Arts by Adrian says, "Best beard of all space and time, not just the
Ooh.
universe, but in all space and time." Randall.
It's like
Well, yeah, I mean, why
Before the
limit it
trim
to
or
just
after
the
the trim?
universe?
and Matheson's
Why limit the glory of my beard and majesty of my beard to mere the whole universe? Why not all time? So
Yeah.
not only the infinity of the universe, but the eternity of all time.
That's right. Exactly. It cannot
So-
be bested.
Just in case that gloriousness is related to Santa, I have presented my wish list.
Oh, that's
Here,
that's what that is.
Santa.
The chat was putting up a collection plate for you, that you lost your house and now you have a van. So that
No, that's one of my wants for next year.
yeah, Brad wants to live in that van. He doesn't have it yet. So the collection plate actually needs to be for the van.
Matheson's
Couple weeks at
website
a
is
time, maybe.
Matheson's website is starmythworld.com.
That's right. Star Myth
There we
World.
go. Star Myth
That was
World.
close. Yeah, thank you.
Yeah, I think it would be great to get him on here.
Yeah,
for
we
a
could
visit.
definitely do that.
Yeah, and I bet he would. Yeah, so here's Chimney Rock. We've made several excursions up this ridge and to see this firsthand, and we're going to try to get back there for 2023 when the alignments come back around again. But let's see here. Yes, so this is, you've got your Chimney Rock Observatory complex right here, and here's the two pinnacle rocks, and they were utilized, these ancient Chacoan people were utilizing this as an observatory to monitor these celestial motions, as we'll see here. Let's see. So this was the fire tower that's no longer here. But interesting, this fire tower was built right over the remains of an ancient signal tower that the Chacoan people used to build huge bonfires up here that could be seen from, many, many miles away. And was part of a whole complex that we're going to talk about when we get into doing a session about the Chacoan culture. We'll look at some of this in more detail. So that'll be coming up at some point. I'm sure this next year we will be looking at some of the extraordinary phenomena of the Chacoan culture in the San Juan Basin of New Mexico, and then extending up into the Four Corners area. But this was one of the signal towers was here that was part of this whole signal system, using great bonfires to, presumably communicate on some level, over the full 10,000 square miles of the layout, the infrastructure of. So here's, looking back at the ruins of the observatory. So this is looking one direction, and when you turn around and look the other direction. And one of the things that was interesting was this ridge, because apparently there were structures along this ridge that marked these positions through the course of the year. So here's your the sun rising between the two pillars. And let's see, we're not going to get into this too much. We'll save this for discussions about the moon, other than the fact that the moon, you can see here that the moon's orbital plane is angled from the Earth's orbital plane by 5.145 degrees. So that little tilt of the Earth's, see, if these two were in the same plane, then we would have eclipses every month.
Yeah.
We would have solar eclipses and lunar eclipses every month. But it's only, again, it's the intersection of those two planes, and the moon has to be, the closer the moon is to that exact point right there of intersection is the more complete, you know, the eclipse is going to be. So here you've got, see that major standstill of the moon path. So rising right there between the two pillars. And this is from the vantage point of the observatory. Summer solstice sun path, minor standstill moon path. And here's the whole calendar laid out on the horizon. And it's quite a spectacular feat that they came up with. And you see summer solstice sunrise path, winter solstice sunrise path, and then equinox sunrise path. So here you can really get a sense of how, from this observer up on this ridge, using the pillars, rock pillars as a, you know, as a reference standard, you could watch this motion and see. So here's the yellow circles is the sun. So it's going to be swinging back and forth. So from here, summer solstice swinging to the south for 6 months. For 3 months, then another to here. Then it makes this return, comes back, and it does this back and forth phenomena. And then juxtaposed on that, you've got the moon paths, you see. And what's interesting about that is that the moon actually oscillates in such a way that it has two minimum and two maximum. So you can picture, if you figure minimum like this, and then maximum like this. So it swings back like this. It'll do the minimum rising and setting, and then it'll do the maximum rising and setting. And that cycle is 18.6 years, and it's that cycle that's coming around in 2023. So yeah, so here you can see
that's a great one.
Yeah, sun is setting, and you see so on the equinox, this shadow will pretty much point due east. Okay, we don't need to get into
the other interesting feature of that in that picture right there, well, the overhead, the wall, that flat wall of the structure they built is lined up with the Crab Nebula.
Yeah.
Remember that? This wall right here.
Yeah.
Yeah, we learned that, didn't we, when we were there?
Like they witnessed that event.
Yeah,
that's just really,
yeah, it's pretty astounding. The whole thing. And, we're just, it's a challenge to try to really understand what was going on there. But, we have these tools at our disposal now that should be theoretically helping us figure all this stuff out, because, we've got, just the tool of the astronomy software that I've got. I'm still trying to learn how to use Stellarium. I used Voyager for many years, but then when I upgraded my computer, it didn't recognize the older version of Voyager. So, and they haven't updated Voyager. So, I guess I'm going to have to maybe dig up. I've got an old laptop somewhere.
Well, we might be able to run that thing in compatibility mode. I can fix that probably, Randall. If I can come down there sometime.
You can help me solve that problem?
Yeah. Well, you still need to use Stellarium, but still, I think we can get your old software working.
Really?
Yeah.
Okay.
I think
that's
so.
good to know.
Yeah.
Because I found the Voyager was a little bit more user-friendly. But I'm learning how to use Stellarium.
Yeah.
So it's got a lot of power to it, and I'm going to be incorporating it into future lectures. But I just want to be a little bit more, have a little more mastery of it before I start using it. But, the images that we were just looking at, those were captured from Voyager. So set those up. So
there you go.
Interesting
so lots of stuff we didn't get to. Yeah, really interesting. But yeah,
So let's briefly, well, since we've got, solstice there, and we found out was 9 o'clock something tomorrow morning, coming up in about 8 or 9 hours. And that will be when the sun reaches that maximum southerly, southerly position on the horizon. And we've talked about how it sort of stalls there for a few days. And so the ancient ritual of the returning of the light was that every day the day is getting shorter, darker, the sun seems to be moving further away, temperatures getting, beginning to decline. We see nature go into decline. Then it gets to the solstice and it hangs there for a while. And then typically 3 to 4 days later, it's obvious now that it's begun its return journey. So you can actually see now that the Christmas celebration is tied to the solstice. And it's not exactly on the solstice because it really is commemorating that morning or that day that the return of the sun, the return of the light has become obvious. So that's something to think about on Christmas, is that there is an astronomical correlation to it. And
that's right.
by 4 days after the solstice, you go out there in the morning and go, yes, the sun, and you're monitoring it on that horizon calendar, right? So now 4 days later, you go out and you're seeing, hey, the sun has moved.
Yeah, it's been born again.
It's been born. It's returning.
That's right.
And this is that myth of the return.
That's
right. The return of the sun, right? S-U-N, but also the return of the sun. So it's really right there is sort of the whole astronomical basis of the Christian mythology.
Mm-hmm.
Which is basically just a repackaging in its own way of the pagan mythology. Brad, you were mentioning earlier about Mithras and many of the other gods that died and were resurrected. But in this case, it's correlated to the sun myth, which is, again, interesting to me. And that's certainly something to dive into further when we get into some of the Grail mythology. We'll be coming back to some of those ideas, and the idea of the esoteric dimensions of Christianity that have sort of been obscured over the years.
Heck yeah, that
sounds good.
Really interesting stuff to me too.
More.
I love it. More. Thanks to the Shermanator Osborne for the super chat. Thanks to everybody in the chats. That was great. Y'all are making us laugh.
Y'all.
We're trying not to
yeah,
laugh.
really.
Yeah,
Randall's being
we
serious.
appreciate it.
We're reading the chats and trying not to laugh. You guys are, We're trying to stay serious here, guys. Making it tough. So, we want to say that the plan is right now that we are trying to do these live streams every other week. So
show up in 2 weeks.
Show up in 2 weeks and we'll be doing another live stream. That's the plan right now. We're seeing how it goes. We just started this.
Yeah, the edited shows were taking roughly 2 weeks for a while. We would get backlogged. So this is the new plan is to do an edited show every other week and do a live stream every other week between those. So
for a while.
We'll see how it goes.
We're seeing how it goes.
Yeah.
People were suggesting that this was an experiment, and yes, it is.
That's right.
Yes.
That's right. And RandallCarlson.com for all your Randall Carlson needs. Anything else, Brad? You got anything else to add?
We do want to mention CBD from the Gods is running a special.
Oh, yeah.
At least up till Christmas. I don't know. Are they going to extend it? But yeah, I mean, I think.
It's supposed to be till Christmas. The RandallCarlson.com/shop was through the end of the year, 20% off.
Okay.
But yeah, CBDfromthegods.com up to 35% off.
And they'll rush it out to you if you order.
That code is support RC.
Ah, different code, new code
is the coupon code for that.
Okay.
Support RC.
Oh, okay.
But what people really want to know is if they can buy stick-on beards in the RandallCarlson.shop.
We're working on it.
Okay.
What we've decided, I've got a big gunny sack out back filled with all of my beard trimmings from the last 30 years. So I've almost got enough.
Mix it in with the stray hair from your dogs.
Well, yeah, I mean, a little of that's going to be mixed in with it, of course, too.
Oh, and thanks to Ancient Sanctum, she's been moderating. So thanks very much to her, and also for the super chat. And yeah, go check out her channel. She's been publishing stuff on mysteries as well. So thank you.
Who is that? I want to. Who is that? We should check out.
And thank you,
Oh, I'm
Ann.
Ancient
telling-
Sanctum.
Ancient
She's
Sanctum,
a big
yeah.
supporter of you guys, and she sent some money several times when we say that we're working on a project or building a studio. So thank you, Ann.
Let me just,
Ann.
since we're doing this, let me share this. Since Mike put all this work into this, let's see. Here we go. From now till December 25th, you can save up to 35% and support Kosmographia. Use this code at checkout. So yeah, Bradley just gave us that. So yeah, you buy their product. It's good product. We've all been using it. We all like it, and it definitely helps us out. So yeah, if you patronize them, it's gonna help us. So
Absolutely.
Right. So yeah, 5% of those sales that come through that special order and using that coupon code percentage will come straight to Randall Carlson.
yeah, and Mike Robertson, our good friend and CEO of HowTube has just sent a little note that says they have people standing by ready to rush any orders that come in before Christmas. So
All right.
people are standing by
There you go.
right
Those
now as we
Oregonians
speak. There
are
are
into
people
it.
standing there holding their vials and their packages of product ready to send it out.
They're bubble wrap. What do you call that? Your interstellar.
The interstellar jumpsuits.
Yeah, interstellar jumpsuit. Man.
Yeah. And hey, couple more here. Thanks to David for the super chat. I see you asked a question. We will try at some point to do a Q&A, and using the super chats, but not this time, buddy. So keep that question, and we'll try to address it some other time.
But you can go ahead and give me the question afterwards. If somebody asks a question, you can give me a list of the questions.
Oh, okay. Yeah. Well, you got to be able to handle them live, like right when they come in, man.
Well, let's see how you handle it.
Bam.
Okay, what's the question?
He says, have
2
you heard
minutes.
of Paul Lavoielet galactic
Yeah,
superwave
yeah.
theory?
Galactic
Oh,
superwave theory.
I don't know. I don't know about that. I read his book years and years ago
Mm.
and was not convinced, but still got an open mind. It just seems to me, my one thought was that the galactic, the galaxy operates on a much larger, longer scale term. If you said that maybe every 260 million years there might be, but every 26,000 years. But I don't know. I need to, at this point, I've learned a lot since I read his book, which literally was decades ago. So I kind of would need to be fair. I would need to reread the book.
Go back.
Okay,
to it,
yeah. So he wants to
And
know
he's
if you can
probably written
explain
some
it. So.
additional stuff.
Yeah,
I know that he's gotten some, some criticism, and I haven't stayed up with that. So I'm not going to accept it or reject it at this point.
Okay.
Well, if you read the book again, will you explain it all to us?
He wants it to be explained. He doesn't. I don't. Yeah. He wasn't asking if you think it's correct or not, but can you explain the superwave theory? Yeah.
To explain that.
And
Okay.
one more. I guess that's Gek812 or GEC812. Thank you for the super chat. Says thanks for the live stream. Love feeling involved.
Yeah.
Well,
Lots of love from the
Cool.
chat.
Yeah, lots of love from the chats. You
Good, we
guys-
like
So-
that.
Yeah, we do. So again, for events and tours and what's up with Randall Carlson and the team, randallcarlson.com/newsletter. It comes out monthly, first Saturday, and some seriously cool stuff coming for 2022. Some live stream lectures and the return to Joe Rogan experience coming in
Yeah,
2022.
That's
We've
right.
got a provisional date set up for February 4th.
Hey.
We've had a couple of exchanging some communications with Joe, and I think we've settled on February 4th.
Awesome.
Yeah, and then when we get back to our recorded Cosmographia, we're going to be diving into some of the incredible stories about the cosmic firestorms. And that's some powerful stuff.
Oh yeah.
So make sure you check in with that. So
Yep.
Well,
All
thank
right.
you,
okay.
Russ, for setting all this live stream action up and letting us experiment with this. It's fun so far. We're gonna have more guests.
Yes.
And we'll do it again 2 Mondays.
Yep, we will. And, we're always learning and getting better at it. So it will
Yeah.
continue to get better. Thanks, people. Good night, guys.
Good night, everyone.
Excellent.
Good night.
January 9th, is that right? Or 10th, I mean?
What are you asking me?
Or
Oh.
January 3rd. Yeah, I'm trying to figure out how 2 weeks is.
Oh, I don't know.
It's
All right.
Monday, 2 weeks from now. Just what you need to do is build a giant stone structure out in your yard so that you can know when the live streams are happening. Good night, everybody.
Perfect.
Good night.
Ciao.
That was perfect.